Here we are at 9E from our target 5. We're asked to solve and graph and give the interval notation for this particular set of inequalities. Now, just looking at this, we do notice that we have an OR statement, so our graph in the end should be something resembling, it doesn't really matter where these are located, but, or they're rather, open or closed, but they should be going outwards. So again, we should see a graph that does something like that. With these OR statements we discussed from class, just pretty much separate these down the middle and treat this left one as its own inequality and this right one as its own inequality. Now, as we go ahead and solve for this left one, all we have to do is multiply both sides by the LCM first. In this case, the bottom number is 2, so we're going to go ahead and use 2 on both sides, and that'll be our LCM. On the left side, we'll go ahead and distribute the 2. 2 times x gives us 2x. 2 times negative 10 gives us negative 20. Is larger than or equal to. On the right side, 2 goes into 2 one time, and so we just have negative 17. Then we're going to go ahead and add this 20 over. That really has nothing to do with the x. So when we do that, we end up with those dropping out, giving us just 2x is larger than or equal to 3. Lastly, we'll go ahead and divide this coefficient 2 on both sides. So then x is all by itself is larger than or equal to 3 halves or 1 1/2. So that takes care of the left one. Let's go ahead and do the right one. Looks like on the right one we notice an LCM here of 40. So we'll go ahead and multiply both sides by 40. And when we distribute, we end up with 40x. And then 40 goes into, 5 goes into 48 times. And then 8 times the 12, we get negative 96. Equals, on the right side, 40s end up canceling out with one another, leaving us negative 61. And now we're just trying to solve for x. So we can add this 96 over from both sides. And when we do that, we end up with 40x. The 96's cancel out with one another, equals 35. Lastly, divide by the 40 on both sides. So these end up canceling now, leaving us with x. Oops, we are dealing with an inequality, my apologies. It is less than. So x is less than 7/8 when you simplify it up. So you divide the top and the bottom both by 5. So 7/8 is our simplified version of this. Going ahead and graphing this now, we end up with a number line that does something like this. And if we have 0 right over here, we notice that 7/8 is actually a little bit closer to the 0. So 7/8 is about right here. And since we are talking about strictly less than, we have an open circle around 7/8. And just like normal, we'll go ahead and test the number. Is 0 less than 7/8? Well, that is totally true. And so because here is 0, it was true. It was on this side of 7/8. That means any of this other stuff would also be true. Next, let's go ahead and graph this one. This x is larger than or equal to 1 1/2. Well, that would be out a little bit more. So 1 1/2 would be out a little bit over here. Testing 0. Is 0 larger than or equal to 1 1/2? Well, unfortunately, no, that is false. This is going to be false. It's not. So on this side, when we tried 0 0, it was false, which means that this side must be true. And we always have to shade towards the truth. Now with our graph, because we have this little bar underneath that is saying that it's larger than or equal to, and that's why we're going to go ahead and shade this little hole in there. Lastly, we just have to give the interval notation. And the smallest thing that x can be here is negative infinity, because it will keep going over to the left. So negative infinity. Now x is going along, because we read graphs from left to right. X is going along until we finally get to 7 over 8. But because we can't be 7 over 8, we have a parenthesis around it. Then x all of a sudden takes a break and then kicks back in at 1 1/2. So at 1 1/2, and because we can be 1 1/2, we open it up with a bracket. And then x goes on forever and ever and ever towards positive infinity. Because we cannot actually obtain positive infinity or negative infinity, we always have parentheses around them. So there is our interval notation. You can put a little u in here, or you can throw a little or symbol. Either one is good. You can use comma even for me. Some teachers might be a little more picky in the future, but I'm good with that. So here is our interval notation. There's our graph, and there we've solved for them. Again, though, that is 9E from our target 5.